Hello and welcome to Special Cases of Factoring. Today we're going to look at two special exceptions to look for, because if you can find this structure in the problems, the answer comes very quickly. The first one is called the difference of squares. What this really means is a difference of two perfect squares. Difference, remember, in math means subtraction. So if we have difference, that means we're looking to have subtraction. And then perfect squares are things that you could take the square root of. So a problem structure is something like this with x squared minus y squared, where we have two perfect squares and it has to be subtraction. If we have perfect square minus a perfect square, then this is considered to be a difference of squares problem. And the answer will always look the same way. The answer structure will always look like this. The square root of the first term, which in this case is going to be x, goes in the first places. The square root of the second one, which in this case is going to be y, goes in the second one. And the signs are always opposite. One's positive, one is negative. So the square root here is first. The square root of this is second. One is positive, one is negative. An example of this is something like this. 4x squared minus 9. So I see 4x squared. That's a perfect square.
Attention staff, if you missed the after-school meeting yesterday, the polls are now open in room 215. Thank you.
Thank you. The last number is also a perfect square because the square root of this is 3 and 3. And this is subtraction, so it's a difference of two perfect squares. So I can go straight to my answer. The square root of 4x squared is 2x. The square root of 9 is 3. And one of them is positive and one of them is negative. This is really nice when you have a really big problem like 121x squared minus 49. You know, that might be really annoying to have to do out the long way. But if you say, hey, that's a perfect square, 11 times 11 is 121, 7 times 7 is 49, there's subtraction, we have a difference of two perfect squares. We go straight to our answer. 11x, 11x. 7, 7, one positive, one negative. Easy. Okay, that's the first special kind. The second special kind is called a perfect square trinomial. So trinomial tells us there are three terms instead of just two. Okay, and the way it works is that the first and the last are perfect squares, just like the difference of squares. But the middle could be positive or negative, and it has to be double the square root of this times the square root of this. So the middle is double the square roots multiplied. When you have something like this, the answer structure looks like this. If it's positive, if this is positive, then it would be the square root here, the square root here, and whatever this sign is going to be the same, plus and plus. If this is negative, then we have square root here, and both negative. So the signs will be the same. Whatever the middle sign is, that's what these both are. Either they're positive or negative. The signs are the same as the middle term. Here's an example for us. Something like this. 4x squared and 25, because those are perfect squares and perfect squares. And let's say I had minus 20x. Something like that. Okay, well now, the way I think about this is a perfect square. The square root is 2x, right? This is a perfect square. The square root is 5 and 5. If I multiply them and double it, do I get the middle? Why, yes, because it would be 10x and doubled would be 20x. So if that's what's happening, if this is double this times this, then this counts as a perfect square trinomial. I don't have to do the box and diamond and all that other stuff. I can just go straight to my answer. I put this one here and here. I put this one here and here. Middle is negative. My sides are negative. Done. Voila. Okay? Another example of this might be something like this, where we have x squared plus 6x plus 9. So I see, hey, this is a perfect square, this is a perfect square. If I multiply them and double it, I get the middle. So I can go straight to the answer. X's go here, 3's go here. Middle is positive, so my signs are positive. That's perfect square trinomials. Have a great day.